Okay, so we're going to continue working on our PID sketch. So far what we've done is we have proportional control set up where we have, we're using a map function right here. And I actually deleted some things, I think. Nope, it's all there. Okay, yep, so we basically have our function here that gets our new servo position. It takes the current value and the set point, finds the difference, and it uses the map function. We're going to now replace this with our PID loop, and we'll start with the proportional control. And so it's a similar process. Basically, the calculation is in the background, very similar to the map function, but this will give us a little more control. We'll also replace difference as error. So our error represents how far we are away from our set point. Okay? And so what we're going to do is we're going to also keep track of time. So we're going to do static. Let's see. We'll come back to that actually. Okay, so in order to get our proportional, so we want to set our output, which is our servo position. So we're going to say, we'll start with a float for the output. So float output equals, and we're going to take the error, and all we're going to do is we're going to multiply it by our constant, our proportional constant. So we'll just call it KP. Okay, and then we're going to adjust this equation later. We'll add in the interval portion and the derivative portion. Okay, and so now we have to have a we'll say const float KP proportional we'll set proportional control constant. Let's actually make this be a capital K, and we'll set this to be whatever, and then we can actually, we're going to come back and adjust that in a minute here. Okay, and so this is the value that we multiply by the error that's going to output us our servo position. Okay, now we have to do some manipulation here too, just to kind of, as we think about what's going to happen. So it's going to take our error, it's going to multiply our error by that, and what we'll call this, actually, let's make this be our offset. So this is how far we want our servo position to be offset from that central position, and we're going to do int servo position equals central position minus offset. Okay, and so what this is going to do is, this is going to tell us how far to move the servo. Well, the servo, we have a central position probably around 90 degrees, or maybe we'll call it a neutral position. How about that? We'll call it neutral position. Neutral position. Okay, and so we got to go ahead and add that in as well. So we'll say const int neutral position equals, say, 90. And you can change this. This is the set. This is the point at which the servo is balanced. Okay. And let's set also const float offset max. So let's say we don't want to change that. And we got offset min too. Const float offset min. So we don't set the servo too high or too low, and we'll set those to be maybe 30 degrees to either side, and we can tweak those too. Or we'll set that to be negative 30. Okay, and then coming back here, so I'm going to say if offset is less than offset min, we're going to set offset to be equal to the minimum offset. And so this is so that like if it's trying to go write it to like negative degrees or something, we don't end up doing that. And then we'll say if offset is greater than offset max, then we'll set these to be equal. Okay, and so let's think about this KP value right now. So, and then what we'll do here is we're gonna, once we subtract these, or we're gonna convert this to an int here, and then we subtract them. Okay. And then we return that server position. So this is a new calculation. So let's think about what value this KP should be at though. So this error is now currently in millimeters. Error is in millimeters. And so currently, or previously when we were using the map function, we would have it go to like 90 degrees, I think, or 180 degrees when it was 15 millimeters away. And so we want it, or 150 millimeters rather. So I want it arranged between say 0 and 150 millimeters, and we want it to be maxed out at 150 millimeters. Let's set that to be say 90 degrees, and we can tweak that later. We'll actually come back and change this to be 90 and negative 90 for now, and then you could change those as you see fit. Okay, so if we want the 150 to give us 90, that means that when our error is 150, we want to multiply KP by our error to get the 90. And so that means that our KP is going to be, let's see, 90 over 150. And so 90 over 150 is about 0.6. So let's make that to be the capital K there. So we're going to start KP at about 0.6, and we'll try that out. And we can adjust this value up and down. And so the ways that we can control this are by tweaking these three values. Okay? And so it's going to, the offsets here represent how far off that neutral position it's able to go. So that would be offset max of 90 would be going to a full angle of 180. Offset min of negative 90 would be going all the way back down to 0. So if we don't want those angles to be so wide, we can tweak these up or down. We can make this value bigger to have a bigger adjustment. And if the adjustment's too small, we can make this bigger. To get if the adjustment's too small, or make this smaller if the adjustment's too big. Okay, and so we can kind of use this to dial it in, and this to kind of control the bounds of it. Okay, and now from here, our next step will be to come back in and add in that derivative element and that integral element. Okay, but right now we've got our calculation here, which is the meat of our function. Let's go ahead and make sure we don't have any errors introduced here. I think we're all good there. Oh. Yep, I have a typo here. Let's see, this should be capital M there. Let's see if we got anything else. Looks like that's it. All right, I think we're good.